This week, we're going to be exploring all about probability. So, what exactly is probability? Probability is when we use what we know to make predictions about what we think can happen. In the primary grades, we explore a lot about the words we use to describe these predictions. We can describe a situation as being impossible, so it could never happen, or certain, that it'll definitely happen, or anything in between. We often use words unlikely, likely, or very likely to describe the probability of a certain situation. When talking about probability in math, we can also sometimes hear the words like chance, likelihood, and odds. We use probability in our thinking almost every day without always knowing it. When reading a book or watching a movie, we might make predictions about what we think will happen next or how it will end. We use what we know about the world to help us decide whether something could happen. For example, is it likely that it'll be sunny one day this week because it's often sunny in May in Canada? We're using our previous knowledge about weather patterns to help us determine the probability. We also know that it's impossible for me to be turned into a toad if you say abracadabra, because we know that that can't happen in real life. If we start to look at how we can use probability in a mathematical context, so with math, we're still using it to make predictions, but those predictions are now based on mathematical data or information that we have rather than on our instinct or what we think is possible. For example, using the words we know to help us describe probability, we can answer all of the following questions. What is the probability of picking blue? If the bag is filled with only blue gumballs, it is absolutely certain that we will pick blue. What is the probability of picking red? If the bag is still only filled with blue gumballs, we know that it's impossible to pick one that's red because it's not there. Now, if we take out one blue gumball and add a red gumball, that could change our answers. So if we ask what is the probability of picking red, it's no longer impossible, but there are still 4 blues and only 1 red, so it's unlikely that we would pick red. What is the probability of picking aqua? If we look at the bag, we see that it's filled with mostly aqua gumballs, so it's very likely that we would pick one out that was aqua. When we describe probability, we're comparing the number of times something could happen to the total number of possible outcomes, so everything that could happen. For example, if we look at a number cube or a die, there are the numbers 1 to 6, each written 1 time. That means that there are 6 possible outcomes. If I describe the probability of rolling a 3, I would be comparing the number of times that happened, so that I roll a 3, to the total number of outcomes. There are 6 different numbers, and the number 3 is only written once. So I could say that I have 1 out of 6 chance in rolling the number 3. If we go back to the paper bag filled with gumballs example, and I have 4 blue gumballs and 1 red gumball, I could say that the probability or chances of me picking the red one is 1 out of 5. The probability of me picking blue would be 4 out of 5, because 4 gumballs are blue and there are 5 gumballs in total. We can also represent the probability of something happening as a fraction. We know that our numerator describes a part, and the denominator is the whole. So for the red gumball, the numerator would be 1, and the denominator would be 5, because there's 1 red gumball, so that's the part, and there are 5 gumballs in total. For the probability of choosing a blue gumball, the denominator doesn't change since we still have 5 total gumballs, but the numerator would become 4. When we test probability in real life, we have to be careful that our experiment is set up to give us accurate results. For example, if I have a spinner that is 3/4 red and 1/4 blue, I could say that it's more likely that I would spin red. In my experiment, I spun the paperclip only 3 times. It landed on blue twice and red once. Someone who only looks at the table and doesn't actually see my spinner might think that I have a spinner that is mostly blue, since that's what I landed on more often. Because probability isn't always exact in real life, because we don't always control life and sometimes things happen at random. When we conduct experiments to determine the probability of something, we have to make sure that we give a big enough sample to get accurate results. What that means is that for my spinner, maybe I would have to spin it 15 to 20 times to really be able to get a full picture of what the true probability of landing on each color is.